All right, so we've talked about simplifying radicals. Now we're going to talk about multiplying, dividing, adding, and subtracting binomial radical expressions. And a lot of this stuff that we're doing today is necessary to be able to solve these equations that we're going to do in the next couple of sections. So a lot of practice problems here where they're not really real life type of problems, but skills that you need to know. So basically, we add radicals like we add like terms. You can only add like radicals with like radicals and like variables with like variables. And a like radical means that it has the same index and the same number underneath the radical. They can be different numbers on the outside, like this right here has a square root of 2, square root of 2. So these are like radicals, but this is a 1 outside and this is a 3, and 1 plus 3 is 4. Same thing here. I've got a cube root of 7, cube root of 7. Now, if this was a cube root of 7y, I couldn't do it. They have to have the same exact base and the same exact index for me to be able to add or subtract them. So when I give you a problem like this and starting off really simple, you can see that they have the same index. The index is 2, and they have the same base, 5x. So all you literally are doing is 3 minus 2, which is 1 square root of 5x, and you would never see me write it that way because I would never put the 1 in front. It would just be written like this. This problem here, different base, same index, but different base. Can't do anything. You're done. Okay, this problem here, different index, can't do anything. You're done. They're completely simplified. This problem here, index of 5, base of 3x squared, base of 3x squared. So basically, I'm going to do 17 minus 15 and get 2, and I rewrite the index and the base. And that's the problem. So adding and subtracting, very simple when you have like terms. Okay, so now let's take this one step further, and we have to simplify it first. We have to find a perfect square factor. So I've got the square root of 12 plus the square root of 75 minus the square root of 3. A lot of times the hint is one of these is going to have a root 3 when you simplify it. Well, this simplifies the square root of 3, square root of 4 times square root of 3, plus square root of 25, square root of 3, minus square root of 3. Right? I got these two from the 12, these two from the 75, which is 2 square root 3 plus 5 square root 3 minus square root of 3. All have the same index and base, so I can add 2 plus 5, which is 7, and subtract 1, which is 6, square root 3, and that's my simplified answer. Okay, so we have that list of perfect cubes back from 6.2 that you should reference here. What is a perfect cube to simplify this? So this would be the cube root of 125 cube root of 2 plus the cube root of 27 cube root of 2 minus the cube root of 8 cube root of 2. Notice these are all the same, so we're going to be able to combine. Cube root of 125 is 5 cube root 2 plus 3 cube root 2 minus 2 cube root 2. All I'm doing is simplifying the perfect cubes here from that list. And 5 plus 3 is 8. 8 minus 2 is 6. I leave the index and the base the same. There is adding and subtracting radicals. Okay, so now we're going to multiply them. And we just FOIL, but you've got to make sure you stay with your terms here. So when I have this problem, I'm going to FOIL, first times first. These are two numbers. 4 times 5 is 20. My outside, 4 times 4 square root 2. The 4s are both on the outside, so I can multiply 4 times 4 and get 16. I leave the root the same. The inside, 2 times 5 are both on the outside, so I can multiply 2 times 5 and get 10. I put the root 2 back on the inside. Here, I get 2 times 4, which is 8, and then square root of 2 times square root of 2, which is just 2, right? It's the square root of 4. Square root of 2 times square root of 2 is the square root of 4, which is just 2. So now I'm going to combine like terms that I can combine. I've got 20. I got the same index, same base, so I can combine those. So that would be 26 square root 2 plus 16. And now I have these two as like terms, so I get 36 plus 26 square root of 2. Again, just a lot of algebra here. And sometimes you can't multiply the numbers in the middle or combine them like terms. Sometimes you can. Okay, so looking at this, we're going to multiply the conjugates. Okay, we're going to go ahead and skip this one. We're going to multiply the conjugates. Same thing. I'm going to go 5 times 5. 25. I'm going to go outer, which is plus 5 square root 7. Inner, minus 5 square root 7. And I always put the number first. You don't have to, but that's how you'll always see it written. And then minus square root of 7 times the square root of 7 is the square root of 49, which is just 7. So you're going to see my middle terms cancel. Anytime you multiply conjugates, the middle terms cancel. I combine 25 minus 7, and I get 18. So when I multiply two conjugates, I always get a nice whole number. Okay, so let's talk about rationalizing the denominator. So this is how you divide. Okay, to divide, we multiply the top and the bottom. So we're going to multiply the top and the bottom by the conjugate of the bottom. So what's the conjugate again? All I do is change that middle sign. So I'm going to multiply top and bottom by square root 5 plus square root 2. Square root 5 plus square root 2. On the top, what do? I distribute. I'm multiplying here, so I've got a 3 times the 1, and then square root of 2 times square root of 5. They have the same index, so I can multiply them. If I were adding, I couldn't add those. But because they're the same index and they have the same index, I can multiply. Plus 3 times square root of 2 times square root of 2. 3 times 1 is 3. Square root of 2 times square root of 2 is just 2. Again, when you multiply two numbers that are both under the square root just disappears. So that's the top. On the bottom, again, I wouldn't do this. Square root of 5 times square root of 5 is 5. I would not show the outer because I get positive square root of 10, negative square root of 10. The middle term always cancels when you multiply conjugates. When I multiply the last two terms, negative square root of 2 times square root of 2 gives me minus a 2. So what can I combine on the top? I've got 3 times 2 is 6. I'm going to put the number first. We generally do. 3 square root of 10. I can't combine this 6 and 3 and put 9. I know you all know how to add that, but this 6 and 9 can't be combined because this has a radical 10 next to it. Not the same index, not the same base. So it stays this way. And then 5 minus 2 is 3. And then now I can simplify. Okay, and I call this the little pretzel method, forms a little pretzel. And I'm going to divide 6 by 3 and get 2. And then this 3 and 3, they're both on the outside. So I get 2 plus the square root of 10. So again, how do you divide? You multiply top and bottom by the conjugate. So the conjugate here is 3 plus square root 6. Okay. So on the top, 4x times 3 is 12x. 4x times square root of 6 is plus 4x square root 6. Nothing I can do with that. On the bottom, I've got a 3 times 3, which is 9. I don't worry about outer and inner because they would cancel, right? 3 square root of 6, negative 3 square root of 6. And then negative square root of 6 plus square root of 6 is minus 6. So now I've got a 12x plus 4x square root 6 all over 3. I cannot simplify because this 4 is not divisible by 3, and this 6 is underneath the radical, so I can't simplify that. So I can't combine this 12x and 4x because this square root of 6 is next to it. So again, it's just a ton of algebra in this section, just a lot of, it's kind of tedious work. It's going to help us in solving problems over the next couple of sections, but not really much else to that in this section.